Hello everybody, I'm Nick, and in this video I'm going to show you what I think is the easiest and simplest way to measure how long a method in your code takes to execute. Now, this can be done in many ways in C#, and in most cases it looks either ugly or you have to duplicate a lot of code in many places. With the solution I'm going to show you in this video, is going to be literally one line of code, or in some scenarios not even that. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell, and for more training check out Chapsas.com. Now, before I move on, I'd like to let you know that I just launched my brand new course, Cloud Fundamentals, AWS Services for C# developers. And thanks to a very generous sponsorship from AWS, this course is free for everyone to enroll. You just click that link in the description, you sign up, you enroll, and it is yours to keep. In that course, I'm introducing you to the most popular services of AWS, especially the ones that us as C# developers will definitely use. And you can actually build real systems with the knowledge you're going to gain out of this course. So even if you are not into cloud at all, or even if you're using another cloud provider, you're gonna find something there to learn, because there's cloud patterns and other practices that you can learn and adopt. And to celebrate the launch, I'm also offering the first 100 of you a 15% discount for any of my courses or any of the bundles at nickchapsas.com. So to claim that, use discount code AWS15 at checkout. And again, a massive thank you to AWS. This could not be possible without them. All right, so let me show you what I have here. I have a simple weather API. I just changed the structure a bit, but it's still the basic weather API. But you know, we just have the weather forecast controller, we have a weather service, and then in here, I have the get weather forecast method, and I have just a bit of a fake random delay to imitate that we're calling an API, and then we just return some randomly generated weather. So if I just quickly go ahead here and I run this project to show you how it looks from the front end, I can simply go to Postman and call weather, and as you can see, I am getting the weather. Now, as you can see, I also have different levels of execution duration. For example, 17 milliseconds, 28 milliseconds, 16, 29. This is this randomizer that I have kicking in. But here's the question. What if I wanted to measure how long a method in my project takes to execute? For example, what if I want to measure how long this method takes to execute? This could be for many reasons: for login, for profiling, for just general performance measuring and degradation over time. There's many reasons why you might want to collect how long something takes to run in your code. I've never worked for a product that we didn't measure how long different things take to execute, to measure it over time and maybe alert on degradation, or try to see how we can optimize it and compare how things run on this type of metal and this type of metal. Measuring and collecting is a vital part of any production application. Now, there's many ways to do this, and there's also different libraries that gather all of those things we know today about telemetry in general, and they bundle all that up. But if you want to have something fairly basic, you can have something like this. You can have a try here and then a finally block. And then what you can do is you can have a stopwatch. So you can have your stopwatch here, and you can say stopwatch dot start new, and then a stopwatch starts here, and then here you might want to stop it, and you might want to do something with that elapsed delta. So you might want to say console dot write line over here, and you can say took stopwatch dot elapsed milliseconds and then ms. And if I do that, what's happening is that both on success and on failure, every time I run this, and I did it 3 times, you can see that now I'm collecting how long this took in milliseconds. And I can also have, for example, here the elapsed method, which is a time span, and then run it with a time span, and you can get this metric instead, which is more accurate. Now, the problem with this approach is that even though you can make wrappers and use disposables and using statements and yada, it still requires you to add that code into whatever you want to measure. Now, there are definitely ways to make this simpler. For example, if you use something like Mediator pipelines, then all your handlers in Mediator can be measured with this sort of pipeline middleware behavior that it has. But in general, it can be tricky, and depending on which libraries you use, it can be possible to be done in a nice way or not. You might require decorators, and it gets complicated. So what I'm going to do is just remove all that, and I'm going to go back to the original code, this code. The experience I want is to just say, hey, you see this method? Measure it. That's it. And to achieve that, I'm going to add a library called MethodTimer.4d. Now, we've talked about 4d before. 4d is sort of a family of libraries, and the idea is that all of them are associated in some way with assembly weaving, which is the process of taking the compiled code and then changing it to inject behavior or modify the behavior. So what's happening is the moment I add that, we're going to go here and we're going to add the time attribute. And that's it. Now we can measure how long this takes. That's the experience we're looking for. So now if I go ahead and I debug it, then as you can see, I'm going to call this a few times when, okay, here we go, it's running. But as you can see in the console, nothing shows up. And I will explain why that is. But if we go to this debug output page, you're going to see that all of our measures are still here. We are collecting how long this method is taking to execute. Weather service, which is the class name, .getWeatherFormat, and then the milliseconds. And this is the default behavior. Now, to show you exactly what's happening and what our code is turning into, I'm going to use the IL viewer of Rider to show you the load code. However, I'm going to show you a more simple method instead of the main async one, because the async one looks a bit more complicated and I want to keep it a bit simpler for you to understand how it works. So I'm just going to say example here, and I'm going to create a public void test method. It's only going to have like a console.writeLine, and I'm going to add the time attribute here. So I'm going to just build this and show you what this code is being converted into. So what's happening in this low-level C# is that now this test method no longer has that attribute, and this attribute was just a marker for our IL weaver, which takes a look at the code and says, oh, I have to do something with this, and then goes ahead and changes the code and wraps that code with a try finally, and then the same stopwatch.stop logic. Now, by default, what this will do is actually use trace.writeLine, which is why you're going to see those messages only in the debug output and not in the main console one. But you are probably thinking, well, okay, but I can't really do anything with this because I don't have access to this trace.writeLine, and I guess I can intercept but it's a bit complicated. And it is, but you can solve that. You can actually completely change that logic. So I'm gonna go ahead and delete this example.cs and create a brand new class called MethodTimeLogger. And I'm gonna turn this into a static class. And this class needs to be named that way. And I'm also going to create a method here, which again needs to have a special name and parameters. And that's going to be a public static void log is the name. And then first I'm going to have a method base. So method base over here. And then I have two options. I can either say long and have elapsed milliseconds, or I can say time span and have the time span. So either time span or elapsed milliseconds, just like in the stopwatch. And then I can also have, if I want, a message. And that's it. Now for the weaver to kick in, this actually needs to have some form of code in here. So I'm just going to add it here. But now if I bring back this example class and I recompile, as you can see here in the IL viewer, now that method is going to be called instead of that trace.write. So whatever we put in here will be invoked in our application, and that can be logging, it can be measuring, because you do have the time span, you have this message, which I'm going to explain what it is, and you have full access to the method base. So anything about the method that is being invoked, you have access into. Now, what I'm going to show you here is basically the simplest thing. So I'm going to create a public static logger field here, because obviously we can't have dependency injection here in any way. So I'm just going to use the global static logger that ASP.NET Core provides. So I'm just going to say logger here, and I'm going to set it in the program.cs. So after you build your app actually has this logger over here, this property. So all I'm going to say is method time logger dot logger is that thing. And now in that method, I can say, and I'm going to start with the basic experience that we had before, which is log trace. And I'm going to have a trace that looks like this. So class, method, and duration. So the first parameter here is method base.declaringType.name. Then we have method base.name. And then we have the duration, which is the time span. I could also just use the milliseconds, but I want the accuracy of a time span. And that's it. I'm just going to go back to the app settings.development and lower this to a trace so I can actually see it in the console. But now if I go ahead and I just run this, then the moment I send a few requests, so 3 of them, then as you can see, I am measuring how long that takes to execute, and I'm injecting my own logger to do something with this. Now you can inject anything you want in here. You can use any of your metrics collection stuff. You can do anything you want, but I'm just showing you the simplest way. And you might have noticed that we also have this message. This message can actually be something you pass along with that timed thing. So for example, in my service, I might want to take into account the days that the users are passing in, because maybe something with 5 days takes 10 milliseconds, but if I have 10 days, does it take 20 milliseconds? Does it scale linearly? Does it, I want to know how things scale with different values. So I am going to pass down a message here, and I can say retrieved weather for, and I can use a parameter, so I can say days over here and just say days. So retrieve weather for days, and this will match this parameter and then pass along the days. Now if I do that and I go ahead and I just run this, then as you can see, 1, 2, 3, both of them have 10 days. If I remove it completely, then the default one is 5 and is being reflected here. And if I say, 15, then again, everything is being reflected from the parameter. So a very easy, simple way to do this sort of thing, both with the custom message, but if you're also just interested in the most generic way to doing this thing, then you have full access to the method base and you can do anything that you want with it. Now, it wouldn't really be a Nick Chapsas video without me talking about performance a bit, so I do want to raise a few things, and I'm going to explain them in this example method. So if I go to the IL viewer, as you can see over here, this is using a new stopwatch every time, and that on paper can be problematic because stopwatch is a class and it will allocate some memory on the heap that needs to be garbage collected. So what I would recommend is either for Simon or any of you watching to replace this to use the brand new, and let me just quickly show you over here, stopwatch.getElapsedTime. So what you do is you get the current timestamp in the beginning of the method, and then you get the timestamp in the bottom of the method, and then you get the elapsed time in the end, which is a timestamp that you can use. And the other thing I'm going to show you in the weather service method. So if I go to the IL viewer for that, you can see that the parameters are actually getting boxed here. So this value type, because it's using string.format or string.concat, these things are getting boxed here, which is allocating, again, extra memory on the heap that we could prevent if we use string interpolated handlers here. If you want to optimize this even further, then those are two ways you can. So I definitely recommend you give this package a go. It can really help you measure your applications. And when you have overlapping time attributes, you can also calculate deltas between different methods that call each other. So it can be very, very helpful. But what do you think? Have you used something like this, and have you mixed it maybe with something like OpenTelemetry, which is what I would do? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons to make it as possible. If you want to support me, you're going to find the link in the description down below. Leave a like if you like this video, subscribe, more to like this, ring the bell as well, and I'll see you in the next video. Keep coding.